Independent and dependent events. It's kind of like what it sounds. Independent events have no effect on each other. So we generally say A and B. So A and B, if they're independent, they have no effect on each other, on one occurring. One occurs doesn't affect the other occurrence. Dependent events though do. The occurrence of one of the events does affect the other. Let me do, I will give you some examples, but I have 5 right here. So let me do A in example 1, and then I'm going to have you try B through E. Let's just write independent or dependent. All right, I'll kind of explain in words. You don't have to explain, just we'll talk about it. So a person pulls a red marble out of a bag. The bag has 5 blue and 7 red marbles, 12 total, and does not replace it. Then a person pulls another red marble out. So what do you think, independent or dependent events? Dependent. By the way, so it didn't exactly state what the second event was very well, but it's just pulling another red marble. So event 1 was a red marble, event 2 was also a red marble. They're dependent, and it's because of this right here. Does not replace it. Right? If they had replaced it, each draw would have had a chance of 7 out of 12, because there would be 7 red marbles out of a total of 12. But the second draw only had 6 red marbles left out of 11. So that probability has been affected by the first one. So those are dependent events. Even though they're both pulling a red marble out of the bag, they're dependent because the second one was affected by the first draw. Try B through E. Let's take 1 minute, try B through E. So next one, a person flips a coin, it's heads, the person rolls a die, and notes that it's a number less than 3. So just tell me, independent, dependent? Independent. Flipping the coin didn't affect rolling the die. Owen picks an apple from a bowl of fruit and eats it. He then picks a banana from the bowl and eats it as well. Dependent, yeah. I was like, I guess you can pronounce it that way. Dependent. Now, I think they should be a little bit more clear here. It was more or less a release date question. So I think they should say, Owen picks a random fruit from a bowl. He randomly picks a fruit, it's an apple, he eats it. Then he picks another random fruit from a bowl. It's a banana, and he eats it as well. I think that would help clear it up a little bit, but they are dependent because he ate it. He can no longer choose the first apple on the second draw. So, Chris picks a chocolate chip cookie. He doesn't want it. He puts it back. Then he picks another. Then he picks a sugar cookie. Independent, because the first choice and the second choice have the same probability since he put the other cookie back. And finally, I'm choosing students to come forward in the class. I choose one student who comes to the front of the room. I then choose another student. Are those choosing of those students independent or dependent? Dependent, because I already chose somebody for the first one, so I can no longer choose them for the second student. All right, so to finish up today, let me show you, there is a formula, or there's actually 2 formulas we can use for independence. And I'm going to use this spinner and some probabilities to show you what it is. So the spinner below is spun once. I'm going to let E be an even number, getting an even number. P is a prime number, and L is a number less than 5. Let's find the following, and then we'll put them together to come up with the formula. All right, so probability of even. There are 4 even numbers up there out of a total of 8 numbers. So we have 1/2. Reduce 1/2. Now I got 2 givens, conditional probabilities for B and C. So this one, E given L. So we're given it's a number less than 5. So I'm just going to cross off these temporarily. We only have 1 to 4 to work with. Probability of getting an even number then. 2 of them, right? Our new sample space is only out of 4. Okay, there's only 4 numbers left. And so that's also reduced to 1/2. right, last one, then we'll put them together. Last one is even given prime number. P is prime. So let me get rid of 8, 6, and 4 are not prime. You can never use 1 as prime either. There's just by definition. So there are 4 primes up there. Even, there's only 1. So just 1 out of 4. Okay. Because we're given that we're in prime numbers, and there's only 7, 5, 2, and 3. There's only 4 prime numbers. So that's the new sample space. 1 even number, 2, out of the total, which is prime number 4. Well, let me put it together here for us. Based on our findings, let's fill in the following, and we're going to figure out independent and dependent. E, look at this. These two are both equal. So it didn't matter if we just did the probability of being even, or if we did the probability of even, given that we were in a number less than 5. It didn't matter, we had the same probability. Therefore, those two events are independent, E and L. So I write E is independent of L, since the probability of E given L was equal to the probability of E. What I like to think of with this is I look at that and I think of just crossing off L. Don't actually cross it off right now, but right, if I cross that off, it's just probability of E equals probability of E. It didn't matter that we were in L, we still got the same result. And the next one, we're comparing E with prime, even with prime. They're different numbers. If you get different numbers, they're dependent. So you can say E is dependent of or dependent on P, the prime. Since the probability of E given P is not equal to the probability of E. Okay, hold on 1 second. This table sums it up. 2 events are independent if the probability of A given B is equals the probability of X. B didn't have an impact on it, knowing that we were in B. There are 2 tests for independence, and this is the first one.